Good day everyone. I'm Ivan, the moderator for this webinar. I welcome everyone to today's webinar, which is HVAC and GMP environmental control for pharmaceutical clean rooms 2025. I want to introduce our presenter for today, Roger Cowan. Roger Cowan is the founder and owner of R. Cowan Consulting Services LLC. I would now like to hand over the floor to the speaker. Over to you, Roger.
Well, thank you very much. And as was said, today is the webinar on HVAC. So I'm starting off with a definition of a clean room. So a clean room is a room in which the air supply, air distribution, the filtration of air supply, materials of construction, personnel, and operating procedures are regulated to control airborne particle concentrations so that appropriate air cleanliness levels can be met. Federal Standard 209E, I think it was. And that's the familiar Class 100, Class 1000, Class 10,000, and so on. Now, over in Europe, EMEA Annex 1, they had their own set of specifications and classifications for clean rooms. Now, EMEA also has specifications for microbial contamination. Now, if we look a little closer at ISO 14644 classification standard, Federal Standard 209E, that's the one I referred to in terms of the Class 100, 1000, and so on. That actually was canceled November 2001, and it was replaced with this documentation, ISO 14644-1. Okay, so let's jump into HVAC, and let's look at the main component of HVAC systems, and that's the air handling unit. Now, I've got a diagram, a cutaway here of a typical pharmaceutical air handling unit. You can see basically it's a big metal box, and you've got air returning from the clean rooms at the bottom right. So diving a little deeper here, an AHU consists of fans, coils, and filters within an insulated metal box. Now the cooling coils in that AHU, it typically circulates chilled water or propylene glycol. Also, pharmaceutical air handling units should be located on a separate equipment space. You should use independent AHUs for different manufacturing areas. Okay, so moving from the AHUs to the clean room itself, here's some design considerations. It's very important that both the layout and the construction of the clean room. Now, construction of the clean rooms, internal particulate generation comes from three sources: the ceiling, walls, and floor surfaces. Okay, so now we're going to move on to airflow patterns within the clean room. There's typically two airflow patterns: non-unidirectional and unidirectional. Now, the first one we'll discuss is the non-unidirectional. The other airflow pattern is unidirectional. Now, when you're talking about unidirectional airflow, there's two types. Again, there's vertical and horizontal. So anytime you're talking about clean room suites, you have to look at differential pressure. Now, you have to have differential pressure between cleaner areas and areas of a higher particulate classification. How about airflow rates? Airflow is measured in various ways. It can be expressed as air velocity, air changes per hour, or percent filter coverage. Now, the other method for measuring airflow rates is called percent filter coverage. It is approximate as compared to the others. How do you measure air velocity? It's measured using a thermal anemometer. Okay, here's a new subject, air balancing. As we've discussed, maintaining a proper pressure gradient between adjacent spaces, it's really important to prevent both infiltration and cross-contamination. How about temperature? So temperature, room temperature for a typical clean room is normally held at about 70 degrees Fahrenheit. Now, relative humidity. Relative humidity is actually of greater importance than temperature because it can have a direct bearing on the product quality. Electrostatic control. So when you have low humidity levels in a pharmaceutical clean room, that can build up static electricity in your equipment. So how do you generate these charged air ions? Use a corona discharge ionization device. The basis of environmental control in pharmaceutical clean rooms is air filtration. Air filtration is crucial. Now, these filters are sealed to the housing using a gel-like seal, and it's important that that seal does not promote microbial growth, and also that it can be easily cleaned. It's very necessary to prolong the life of terminal HEPA filters to have pre-filters. The subject of HEPA integrity testing, another word for this, of course, is leak testing. HEPA terminal filters are tested for leaks using the DOP, or dispersed oil particulate method. Now, to perform this leak testing or integrity testing, The air upstream or downstream of the HEPA filter is measured for particulate using what's called a light scattering photometer. It's essential to have an automated control and monitoring system. Now, this system performs its control tasks based on a set of alarm control and monitoring points. Now, a quick note about personnel here. Personnel are the biggest source of microbial contamination in the clean room. These coverall suits can be either disposable or reusable. Okay, so another topic here that's important for environmental control is cleaning and sanitization. It's an essential part of environmental control. Now, when you're cleaning the room, that's absolutely necessary prior to sanitization. Really important that your SOPs for cleaning and sanitization are comprehensive. Okay, so we've talked a lot about HVAC and the different controls. How do you validate your HVAC system? It verifies that the individual components of the HVAC system, there's a pressure differential stress test. Now, what you're doing in this test, also you'll want to do a power failure and recovery test. So those are OQ tests. You'll want to go to the PQ. As part of the PQ, you'll also want to do an airborne bioburden test. So that brings us to the end of the webinar.
Thanks very much for listening. I know it was a very long and detailed webinar. So if that's it, I'd like to thank everybody for listening, and there's a lot of detail there. Hopefully each and every one of you has got some little nugget of information out of this webinar that you can use in your own facility. So thanks very much for listening, and you can look for other webinars that I do as well. One that might be good for you guys is the environmental monitoring that I have a separate webinar on, and that's versus environmental control.
Thank you, Roger. That concludes the session for today. And if anyone has any more questions, please feel free to reach out to us via email. And thank you everyone for participating. We may all disconnect now. Have a great day. Bye-bye.
Thank you.